Okay, question number 11. There's a rotating sprinkler at the fixed point of S. It borders all points inside and on the circle of radius of 20 meters. Point S is 14 meters from the edge of the path, which runs in a north-south direction. The edge of the path intersects the circle at point A and B. The information shown in the following diagram. So this must be the point of S, right? So there's a 20 meters circle here, and then that's it. Show that the distance AB, this chord line AB, is 28.57 corrected for significant figure. So you need to show this distance here becomes this 20.57. So what we know is that from this right triangle, so we know that this we can calculate distance of this distance times 2 will give us the distances, right? So let's put this distance from A to the S to the X. So from Pythagorean theorem, we can say 20 squares equals 14 squared plus x squared. So x equals square root of 20 squared minus 14 squared. So we can use GDC to calculate this value. So square root of 20 minus, no, not 20, 20 squared minus 14 squared. So which is 114.2829. So distance A to B distance equal 2x equals this times 2 is 28.57. So 28.57, that's it. The sprinkler rotates at a constant rate of 1 revolution per every 16 seconds. Show that the sprinkler rotates through the angle of pi over 8 radian in 1 second. So it says is a sprinkler rotates at a constant rate of 1 revolution per every 16 seconds. So it's 1 revolution is 2 pi radian divided by every 16 seconds. So we need to find when in 1 second. So in 1 second, it's gonna be x. So in this case, x will be this cancels out. This becomes 8. So we can say pi over 8 radian per second. So that's true. This one here, okay. Let t seconds be the time that A to B is watered in each revolution. Find value of t. So we know that this sprinkler rotates from here, say 1 revolution. 1 revolution, it takes how long? 16 seconds. So is angular velocity is this one. So it rotates pi over 8 radian per second. So we can make an equation. So it takes 1 second for this sprinkler rotate over pi over 8 radians. So you need how many seconds large t over this angle? T over this angle is the angle of this angle theta, right? So angle theta, where the angle theta can be found Yeah, you can see that this angle here, this angle is half of theta is a cosine. There's a cosine value here because this is right triangle. So let's say this angle is alpha. So let's say cosine of alpha equals 14 over 12. So alpha is arc cosine 14 over 12. So theta we can say is theta is 2 times arc cosine 14 over 20 equals 2 times arc cosine over 14 divided by 20 equals this is theta, so right, so theta equals 1.591. So the value of t that we want to calculate, so value of t equals theta is this value, so theta 1.591 divided by pi over 8 equal this value divided by pi over 8, so it's going to be 4.05 second. Okay. Question 11 continued. Consider one clockwise revolution of the sprinkler. Let time t equals 0. Water crosses at the edge of the path A. So when t equals 0, is sprinkler is over here. And then at time t second, the water crosses the edge of the path at a movable point D, which has a distance small d meters south from point A. Let alpha is angle ASD. This angle is alpha. Let beta is SAB. This angle is beta. And then measured in radians. The information shown in the following diagram. Okay, write down the expression for alpha in terms of t. So we already found out the angular velocity is over 1 second. It rotates over pi over 8 radians. So we know that it rotates pi over 8 radian for 1 second. Then we need to find out for t second the angle will rotate for alpha. So in this equation we can say that alpha is pi over 8 times t. So this is the answer. So this is the between alpha in terms of t. It is known that the beta is 0.7754 radians. Correct to fourth significant figure. By using the sine rule of ASD, show that distance d at the time t can be modeled by this. From this triangle, we can find something. So this distance is known to 20. There's alpha angle. Angle beta is kind of fixed angle because sine of beta is 14 over 12. This is sine of beta. So 14 over 12. So you can easily calculate the beta angle. Beta angle is a constant angle. Alpha angle is something varies depending on the angular velocity. It says by using the sine rule of a triangle ASD. So this is d distance, so sine alpha and d distance, there's sine rule, and this angle and this distance. So we can apply the sine rule. How? So we can say this angle here pretty much equals pi minus alpha minus beta, because all the summation of all the angle inside a triangle is pi, so subtract alpha and subtract beta will give us a that angle. So apply the sine rule, we can say d over sine of alpha equal 20 over sine of pi minus alpha minus beta. Because alpha is this value, we can input here, so we can say d over sine alpha is pi t over 8. Pi t over 8 equals 20 over sine pi minus beta. We can write down first because we know the angle beta, minus alpha. Alpha, we already said alpha is pi t over 8. Pi t over 8. So this angle we can calculate pi minus beta. So pi minus beta. Beta angle is because sine beta is 14 over 12. So beta is arc sine 14 over 12. 14 over 20, not 12. Arc sine 14 over 20. So arc sine 14 divided by 20. This is beta angle. So which is 2 point. So pi minus sine arc sine 14 over 20. That angle is 2.37. So this one here is 2.37. So simplifying this equation, we can say d equals 20 times sine pi t divided by 8. Everything divided by sine of 2.37 minus pi t over 8. So which is same expression like this. Okay, the turtle walks south along the edge of the path. The time t seconds, turtle's distance 3 meters south of A can be modeled by like this. So turtle's position after 3 seconds from A, this is turtle's position located. So turtle's position can be modeled by this function. At t equals 0, state how far the turtle is from A. So t is at 0 seconds. So just inputting 0 over here, it says g of 0. So g of 0, as you see, so it becomes 0 plus 18. So it's going to be 18 meters. 18 meters south from A. Okay. So let W represent the distance between the turtle and point D at the time t seconds. Using the expression gt and dt to write down the expression for W in terms of t. So he says the W represents the distance between the turtle and point D. At the time t seconds. Use the expression gt and dt So point D is where the sprinkler shoots, right? So point D is defined by the function of this function, which is this function. And then GT is turtle's position. It's defined by this function. So we can express the W is distance between those two functions. So W we can express like GT minus D of T. So because its distance cannot be negative, so we can put absolute value. So it's gonna be absolute value of GT is 0.05 T squared plus 1.1 of T plus 18 minus dt. What was it? 20 sine pi t over 8. So 20 sine pi t over 8 divided by sine, remember it was 2.37 minus pi t over 8. Let me double check. Yeah, that is correct. So this question G number 1 is like this. Hence the find when and where on the path the water force reaches turtle. So mode, go to function and see. So first function is 0.05 x squared plus 1.1 of x plus 18. This is y2 function is position of the turtle. And then position of a sprinkler is defined over, this is denominator, numerator, denominator function. Top is 20 of sine. So another thing here, and then pi x divided by 8, close the parenthesis over here, and denominator will be sine of 2.37 minus pi of x divided by 8, close parenthesis. So we need to find point where these two graphs meets. Okay, so see that these two graphs meets over here. So when t equals 3.35, so when is when t equals 3.35, and then position of the turtle, and then position of the sprinkler same. So d equals d equals 22.24. So it's going to be 22.2 meters south of point A. So this is going to be the answer.